Welcome to another episode of Software Explorations, Concept and Overview, hosted by yours truly, Tech Coach Ralph, where we're engineering to win. In today's episode, we are going to be talking about one of my favorite topics of all time. We're going to be talking about data engineering. Shout out to my guy, Mitch and Mr. Lot, two data analysts and data engineers that I know, and I am so proud to know them and all the amazing work that they're doing. But we're going to get into it, talking about data engineering. What's it all about? So let's not waste any time. Let's just jump right in. All right. So data engineering, understanding the role and the responsibilities of data engineers. Like I said, salute to Mitch and Mr. Lot, two people that I know in data, amazing human beings, and they do amazing work, always getting it in. So let's get started. All right. So what is our agenda for today? We are going to be going through the definition of data engineering. Who are data engineers? What are their core responsibilities? The key skills for data engineers and data engineering, the workflow that they follow, the tools and technology that they use, how they collaborate with other teams, the challenges that they face, the future trends, and we're going to look at, and then we're going to wrap it up. And then I also want to go and look at some data about data engineers and data engineering, and give some insight about how data is all around us everywhere we go. All right. So let's jump into it. All right. So what is data engineering? So data engineering is the field of design and building systems and infrastructure to collect, store, process, and analyze large volumes of data. It plays a crucial role in the broader landscape of data science and analytics by ensuring that data is available, reliable, and organized for analysis. So why does it matter, right? So it matters because you get to do, and I think we're going to go through each one of these one by one, but why does it matter? Why does data engineering matter? So it helps you make data-driven decision-making, scalability and efficiency, data quality and consistency, diverse data sources, getting them from different spots, real-time data processing, advanced analytics and artificial intelligence, the cost efficiency, compliance and security, facilitating innovation, and enhanced collaboration with other teams and things like that, all right? So let's jump into it. So what is data-driven decision-making? So data engineering provides the foundation for organizations to harness the power of data and for strategic decisions. A lot of times back in the days would go based on how we feel and what we see, but the data tells a different story. What story does the data tell? Well, through data engineering, through data science, through data analytics, we can make some more well-informed decisions on how we're going to move forward. By ensuring data is collected, processed, and made accessible in a usable format, data engineers enable analysts and decision makers to derive insights and make informed choices, just like what I just said. Scalability and efficiency. As the volume of data grows exponentially, data engineering ensures that data infrastructure can scale to meet demand. So pretty much the things that are processing the data, that are ingesting it, that are putting it out, that they grow to meet the size of the data that's coming in. So as you get more data, your architecture, your framework needs to grow to be able to manage that data, right? Efficient data pipelines and storage solutions are crucial for handling large data sets without performance issues, because we can't have it crashing, slowing down, things like that. We need to be able to process the data expeditiously. Data quality and consistency. Data engineering practices help maintain high data quality and consistency, which are critical for reliable analysis. By implementing robust data cleaning, validation, and governance processes, data engineers ensure that data is accurate and trustworthy. So, integration of diverse data sources. Modern organizations often deal with data from various sources, including databases, APIs, Internet of Things, devices, and social media. Data engineering facilitates the integration of these disparate data sources into a cohesive data ecosystem, enabling comprehensive analysis and a unified view of the business. So think about it like this. Let's say you have a company that does marketing on a bunch of different social media platforms. Let's say Facebook, X, Instagram, YouTube, Reddit, and TikTok. What else is there? Let's say Rumble, whatever there might be, right? Whatever there might be. And so now you have different sources of data coming from all these places. And let's say you're also checking for what devices that they're using and things like that. So now you need to be able to get all that data and normalize that data to be able to see, okay, so to be able to count the views from all the different sources. and to count the likes from all these different sources and see, okay, if I post the same thing in all these places, where is it getting the most traction? Like, where should we focus on marketing more? So that's like diverse data sources. Data engineering facilitates the integration of these disparate data sources in a cohesive data ecosystem, enabling comprehensive analysis and a unified view of the business. All right. So exactly what we were just talking about. So real-time data processing. Many modern applications such as fraud detection, personalized recommendations, and Internet of Things systems require real-time data processing. Data engineering supports the development of real-time data pipelines and streaming and analytics, enabling timely insights and actions. All right. So let's keep going. So advanced analytics and artificial intelligence. Advanced analytics, machine learning, and AI models require large volumes of high-quality data. Data engineering provides the infrastructure and the tools necessary to pre-process and transform data for these complex analysis, thereby powering sophisticated and analytical models. And a lot of times what's happening is the data engineers, they facilitate the ability to take in the data, clean it up, so that they can provide it to the scientists and to the analysts, so that they can do their magic with it. But being able to ingest that data and cleaning it up and normalizing it is what's needed for everything else to happen. If you can't do that, then you're not going to get anything else. Cost and efficiency. By designing optimized data architectures and leveraging cloud-based solutions, data engineers help organizations reduce costs associated with data storage and processing. Efficient data workflows minimize resource usage and improve operational efficiency. Compliance and security. With increasing regulatory requirements around data privacy and security, data engineering ensures that data systems comply with legal standards. So this is a component of cybersecurity inside of data engineering. Implementing proper security measures, access controls, and data encryption helps protect sensitive information. Next up, enhanced collaboration. Data engineering fosters collaboration between different teams, such as data scientists, analysts, and business units, by providing a unified platform. This shared infrastructure ensures that all stakeholders have access to the same high-quality data, promoting synergy and efficiency. So basically, the data engineers, they'll take, let's put it like this, because I used to do some of this work back a couple of years ago, where we have data coming from a bunch of different sources, and we take all that data and we create pretty much a new database that can store all that data in a clean way, combining it, getting rid of the things that aren't necessary, because the things that aren't necessary, they'll still exist in those other databases, but coming together to get one dashboard, one source of data, one source of truth that says, okay, this is the data that we're going to be making our decisions based off of. So who are data engineers? Data engineers are professionals who design, build, and manage the infrastructure and tools needed to collect, store, process, and analyze large volumes of data. They play a critical role in ensuring that data is available, reliable, and prepared for analytical or operational use. They are the MVPs, all right? Because so many companies are making decisions based on data nowadays. And to have this team of engineers who can come and normalize the data, make it available, make it in a nice presentable way, that is critical to mission success. Now, what are the key roles of data engineers? So they build data pipelines, database management, data integration, data quality and governance, performance optimization, collaboration, and tools and technology selection. So pretty much they do all of that. Anything that's related to data, they make it happen. And with the collaboration, there's data scientists totally different from data engineers. Data scientists, they'll crunch the numbers, see what kind of decision we should make based off what we're getting. But the data engineers are the ones who provide this level of detail so that they can do their thing. So what are the skills and qualifications to be a data engineer? So some will say that it's not really required, but I'm going to say that it is highly, highly favorable having strong programming skills, especially like in languages like R and Python and things like that, because you help yourself stand out, especially for data engineering, because you're gonna be manipulating a bunch of numbers. You're going to be taking in numbers from different sources, tools like libraries like NumPy, like pandas, pyplotlibs, scikit, things like that, right? Also database management, because knowing how to do these queries, whether like you're using SQL queries or no SQL queries like through MongoDB or something like that, you need to know how to be able to intake the data, how to like select the queries, how to do joins, left join, right join, inner join, outer join, all these type of joins, right? So many different things, and how to carefully pull out the data from so many different databases. And that's why like all those joins are so important. Data warehousing, where are you going to store this data? Big data technologies, ETL tools, extract, transform, and load. Like how to use these tools. Like I think, what was I using back then? I was using SSMS for Microsoft SQL databases and stuff like that. MS SQL databases. We have cloud computing, data modeling, problem solving. Of course, like problem solving. Like that is like everything else that I just named. Right? Those are like having those type of skills. But problem solving is what all engineers do. Give us a problem and we'll get you a solution. And then communication on how to communicate with the different teams that you're working with, communicate the data that you're finding, what are your needs are, what are your challenges, all that good stuff. So what are some roles and titles in data engineering? So we have data engineer, of course, data infrastructure engineer, ETL developer, ETL stands for extract, transform, and load, big data engineer, data architect, analytics engineer, right? So some titles that you can look for that are within data engineering to see like which one would be more suited to whatever you're looking for. So what are some career paths for data engineering, right? The career path for data engineer often involves starting in roles such as a database administrator, data analyst, or software engineer, and then specializing in data engineering. And database, like all these things are closely related. Database administrator, you might be working with MySQL, MS SQL, maybe Mongo, what is the other one? Postgres. There's so many different databases that you'd be working with. Like there's a database called Cassandra. So many different databases, right? That you need to get familiar with, and like how to query data, how to create the database, how to make sure that the set up the schema and things like that. There's the data analyst who's getting the data and who's processing it and making some type of like understanding what it's telling you. And then you have and then there's like software engineering, specializing data engineering, right? With experience, data engineers can advance to senior roles, lead data engineering teams, or move into data architecture and data strategy positions. So what is the impact that data engineers have on organizations and our lives, right? Data engineers are crucial to the success of data-driven organizations. They ensure that high-quality, reliable data is available for analysts, which in turn support decision-making, operational efficiency, and innovation. Their work underpins the data infrastructure that allows businesses to leverage data as a valuable asset. And data is the number one valuable asset that you can have because it tells you a story about who your customers are and helps you make decisions on how to better market to your customers, how to better serve the needs of your customers, and everything in between. So what is the workflow for data engineering, right? So number one, requirements gathering is like what are the requirements that are needed, right? Data ingestion, where are you getting your data from? Data storage, where are you going to be storing that data? Next up, data processing, how are you going to process the data that you're getting, that you stored, that you ingested? Then how are you going to integrate that data into other areas? Now, what is the quality of your data? Because if you have crappy data quality, then you're going to have crappy information, crappy decisions to make. If you have strong, high data quality, then the better decisions you're going to make. Performance optimization, monitoring, collaboration, and then deploying your tools, your pipelines that you built because the data engineers, they're going to be looking for a way to automate the process of number 1 through 9. And through deployment, that's what they're going to automate it so that it's just like running on a cycle, always delivering the data at a particular time to whoever needs it. So what are some tools and technologies that data engineers use? So ETL tools, extract, transform, and load, right? So Apache Airflow, we did some streams early on about Apache Airflow, trying to get it to work with Selenium Wire. That was a really good experience. AWS Glue, I haven't heard of that one yet. I'll look into that. And Google Dataflow. Data warehousing, Amazon Redshift, Google's BigQuery, and Snowflake. I've heard of Snowflake. And I've heard of Amazon Redshift as well. Big data processing would be Apache Hadoop. I forgot when, but I dabbled in Hadoop a while ago. Apache Spark. So data integration tools, Apache Kafka. I have used Kafka before. Talend. Programming language would be Python, SQL, and Scala. And to add to that programming, there's also R. There's also R that is getting very, very popular. So all those things, you definitely want to look out for those. So how do data engineers collaborate with teams, right? So with the data science, With the data scientists, they provide clean and well-structured data for analysis and modeling. With the data analysts, they ensure that the data is accessible and understandable for reporting and insights. So the data analysts get the data from data engineering, from the data engineers, and then they create these nice little reports with Tableau and whatever other tools that they use. Software engineers, the integrating data solutions with applications and services. So take this for example, right? Like if the data engineers need need information to come in a particular way, they can make, okay, software engineers, can you do this so that we can get the data that way, and then we can run our pipeline, set up our pipelines in the right way. And then the data analysts, they can see the insights that's going on and say, hey, we noticed this trend. Software engineers, we need you to do this so that we can do better. Like the company can do better, our organization can do better. We can make a bunch of money, right? Business stakeholders, understanding the business needs and translating them into technical requirements, right? And what challenges do data engineers and data engineering face, right? So data quality, ensuring the accuracy and consistency of the data. Scalability, designing systems that can handle growing amounts of data. So as your organization grows, you're going to be getting more data and you need to be able to properly handle that. Data security, protecting sensitive data from unauthorized access. So making sure people don't have access to like HIPAA information, to credit card information, to whatever, like, social security type stuff. Protecting the sensitive data, maybe like, keeping certain stuff out of the database, but being able to count it properly. And then real-time processing. Implementing systems for real-time data processing and analytics. That's like getting things in real time is always tough, because the closer you can get it to real time, the more accurate and the better decision that you can make. The further, there's a big difference between 5 minutes delay and getting it in like 30 seconds. And data engineers are always trying to get closer and closer to getting it right away so that we can make decisions in real time. So what are some future trends of data engineering? So automation, increased use of automated tools for data integration and pipeline management, real-time data processing, growth in demand for real-time analytics and streaming data. Also, AI and machine learning. So artificial intelligence and machine learning, integration of AI to optimize and automate data engineering tasks, and cloud-native solutions, greater adoption for cloud-native data engineering solutions. All right, so those are the future trends. So in conclusion, we spoke about what the definition of data engineering is, who are data engineers, what are their core responsibilities, what are some key skills that they need, what workflow do they follow, tools and technology that is used by data engineers, and how they collaborate, how data engineers collaborate with other teams, including data scientists, data analysts, software engineers, business stakeholders. What are some of the challenges that face data engineering and data engineers? What are the future trends? Where is data engineering headed towards? And lastly, if you have any questions, then go ahead and drop me a comment in the chat, and I'll make sure to get that addressed. I might have to reach out to one of my guys, Mr. Lott or Mitch, and have them drop that massive knowledge that they have on us, and we'll go from there, right? So that is our presentation. But wait, let's go to full screen. There is more. Yes, there's more, right? So what is the more that we have? So I wanted to do this real quick, right? Let's go. I want to do this. So I want to go and look at some data engineering projects, right? Because for me, I'm a big project guy to do something useful when I'm learning and stuff like that. And that's how we're able to do learn about with Terraform, learn about Elastic Beanstalk and all this type of stuff, because we needed that in order to set up the Poopy Pants application app where we're getting the different quotes. So let's take a look at some projects that, as you're learning data engineering, that can help you to be set apart from your competition. All right. So let me see how I'm going to share this screen. All right. So I pulled up this site, which has 7 end-to-end data engineering projects that sets you apart from the rest. And it's by Youssef Ganiyu. And I just wanted to take a look at some projects that could be created for data engineering. And maybe we'll take on one of these projects in the near future, right? So let's go. This is a very nice setup, by the way, I must say. Very nice setup. But so real-time change data capture streaming end-to-end data engineering project. So this one is we deep dive into the world of change capture data and how it can be implemented for real-time data streaming using a powerful tech stack. So And here's why I like to get hands-on, right? Because in this tech stack, we'll be using technologies of Docker, one of my favorites, Postgres, SQL, that's what I was thinking about earlier, Debizium, Kafka, Apache Spark, and Slack to create an efficient and responsive data pipeline. And so you'll learn how to configure and save data into Postgres SQL database, configure and capture changes on Postgres SQL with Debizium, stream data into Kafka, and add a stream layer on top of Kafka and Apache Spark, Flint, Storm, or KSQLDB, right? So and this must be Youssef, and he has a video on YouTube about it, which that's pretty cool. So I mean, we can probably like take on this project as well. Reddit data pipeline engineering, AWS end-to-end data engineering, and this project, this one you'll be using Apache Airflow with Celery and Postgres, Docker using Reddit API, AWS Glue, AWS S3, AWS Athena, and Redshift data warehousing. And honestly, with me, like I'd probably even throw this in like setting up the infrastructure via Terraform, and then going through this project to like set all this stuff up because it looks like super cool, right? Real time socket streaming, showing you how to do all this type of stuff, sales and analytics and Apache Flink end-to-end data engineering project. All this different stuff is really cool, right? And lastly, what I wanted to do is look at Glassdoor to see what kind of money do data engineers make, right? So all years of experience between 108,000 and 160,000, right? If we were to go down to 0 to 1 years of experience, you're looking at like, so according to Glassdoor, looking at starting around like 84K to 141K, which is not, it's not bad. Not bad at all, right? Not bad at all. Let's see. So let's see. What else do we have? Let's say if you are at a good 5 year mark, 4 to 6 year, you're looking at 108 to 178,000. If you're at 7 to 9 years, again, 119 to 196K. 15 years plus, you are at 158 to 254K, right? All industries and anything else. So like Meta, top paying companies, Meta is looking at like 260,000, Airbnb 251,000, Roku 250, Dropbox 240, Google 237, Apple is 236. So like data engineering, you see, look at this, Amazon data engineer one, between 114 to 160, averaging around 134. Meta data engineer 260, Amazon Web Services 136, Cisco 227. So data is king. All right, I'm going to go back to full screen. So yeah, data is king. Data is king. Like there's no way around it. But here's the thing, right? I told you that at the beginning, you use data everywhere. So and here's how. I'm going to give you an example. How many people play fantasy football? Are people making these decisions based on how they feel, or are they looking at the data? Are they looking at injury reports? Are they looking at who are they playing? What like so let's say you have to choose a quarterback for something, like a quarterback for a week, and a running back, and you're like, okay, who are the running backs that I have on my team? What defense are they going against? What is their run stop defense? Maybe they're going to give my running back a hard time. Who's my quarterback? What defense is my quarterback going up against? Maybe I should put my other quarterback instead, because like they might be going against an easier team. Does my team have a bye week this week? Like, does my defense have a bye week? Do I need to put in my other defense? So that level right there, do you know how much data is being used for you to play fantasy football? And we have data engineers who are taking that data and making it available to you so you can make your decisions. That hopefully, your fantasy football team can be the thing, can be it, right? Another example, in basketball, back in the days, if a player like Steph Curry would have stopped at the 3-point line on a fast break, wide open layup, and shot a three, they would have been buried under the gym. But now, due to data scientists, data engineering, it's like if Steph Curry does not stop at the 3-point line to take the three, then he might be buried under the gym, right? It's simple as that. Data has revolutionized sports, entertainment, whatever. When what do you think it is when they're like at the end of like when a new week starts and they look at how did a new movie do at the box office? That's all they're saying. Oh, this movie made $83 million. That's data. And how do you think they got the data? So they take every like the movie ticket sales are being funneled into one like to some databases, and now that information is being processed to be able to share this information so that people can make decisions based off that. Data is all around us. It is used for everything. When you're going to buy a car and they run your credit, that's data. And they say, oh, nope, no car for you. No car for you. Data is all around us. And I just wanted to break this down because the works that my friends like Mr. Lott, that Mitch do is so super incredible. That's why I had to go back and revisit, because as I'm building these apps, I'm going to start getting data, and I want to be able to analyze that data and make the right decisions with that data, build my own data pipelines, because why not? Why not? Why the hell not? All right. Anyways, I'm going to get out of here. Thank you guys so much for tuning in and for listening and watching this video on data engineering and how data is king and how data engineers are the real MVPs, because without data engineers, guess what? You would not have your fantasy football team. Nope, because you wouldn't know what you're doing. But the data engineers make it happen. So shout out to the data engineers who allow us to play fantasy football, fantasy basketball, fantasy baseball, fantasy rugby, and fantasy lacrosse. All right. Anyways, I'm getting out of here. Thank you guys so much for tuning in. If you haven't done so already, do me a big favor. Go ahead and like the video, share the video, subscribe to the channel, hit the notification bell so you can know every single time we go live. And if you are in need of one-on-one coaching from me, Tech Coach Ralph, then go over to www.techcoachralph.dev, where you can sign up for a coaching plan as well as get access to exclusive content that is not on YouTube to help you level up in your career. So on that note, thank you guys so much for tuning in. This is Tech Coach Ralph, and we are out.
If you enjoyed the fascinating information shared in this video and you want more, be sure to hit the subscribe button to Tech Coach Ralph to be notified for new videos.